Hello, this is Coach Meinbauer, and I'm here for AP Precalculus for topic 2.2, which is changing linear and exponential functions. And what we're going to do is we're going to relate these things off of 2.1, which were exponential sequences, which was geometric sequences, and linear sequences, also known as arithmetic sequences. So first things first here is for my arithmetic sequence. You can see the equation there and how it relates to the linear function. So essentially, these are very, very similar, where the a sub n is like my y value, the d is my slope, the n is my variable, and then the a sub 0 or a naught value is my initial y value. And we can also express both of these as the different forms, and you can kind of see how on the left here I have my based on a known difference from the kth term, and then on the right that's my based on knowing the slope at a point, okay, also known as point slope form. So here are some examples here. So example, not really one, but first example here. So given an arithmetic sequence, 3 blank blank 15, write an expression for the nth term. So for this, all I know is that a sub 1 is equal to 3. A sub 4 here is equal to 15. So I'm going to express this as a sub 4 equals a sub 1 plus d n minus 1. Well, actually, my n value is what now? My n value is 4. Okay, so this is me expressing this with n equals 4 and k equals 1 from this form right up here. Okay, so a sub 4, which I have, is 15, equals a sub 1, which is 3, plus 3d. So subtract 3 from both sides. We get 12 equals 3d. Divide both sides by 3. And d is equal to 4. So now I have d is 4. I can now express this a sub n. Express this really as this down here, but replace my 4's with n's. So a sub 1 plus 4, n minus 1. I can rewrite now a sub 1, which is 3, which I already knew that, plus 4, n minus 1. You can distribute that 4 if you want. It's not going to matter. This is a totally 100% correct answer. Now, relate that back to when we were given two linear given linear function with inputs and outputs. So we have a linear function, we have two coordinate points. So really our slope, same thing as our d value. How do you find our slope? Well, we use point slope form, which is y2 minus y1 over x2 minus x1. Okay, so 15 minus 3 all over 4 minus 1, which is 12 over 3, which is 4. Okay, so knowing that, which makes sense because I just said my d is my m, so that is 4. So now using my point slope form here, I'm going to get y equals, I'm going to pick this one right here as my y1, and this is my x1. So equals 3 plus m is 4, x minus 1. And that is one of the two correct answers, or actually there's many different correct answers I could have. I just picked 1, 3 as the point. If you notice how similar they are, well, it's because they're the same thing. All right, now let's take this and let's put this into a application problem here. So we have a large theater that has rows of seats where the numbers of seats in each row can be modeled by an arithmetic sequence. If the 5th row has 31 seats, the 11th row has 49 seats, determine how many seats are in the 25th row. So what we're going to do here is I'm going to name this, looking for seats, right? So S of n, I'm going to name this as a function. This is the number of seats. Okay, so what do I know about S sub n? So S of n equals, and I'm going to use this formula up here, this a sub n equals a sub k plus d n minus k. So S sub n, and I'm going to plug in, well, what do I know? 5th row. Sorry, I'm kind of like, whoa, get a headache. All right, so my 5th row, I'm going to write that over here. S sub 5 is 31. I don't know why it's writing so poorly. It's 31, and I know S of, whoa, S of 11 is equal to 49. So S sub n is going to equal, if I'm using the kth term here, S sub 5. I'll plug in 11 in a moment. S sub 5 equals plus, plus, I'm going to use m for slope because I'll relate it back to, since I'm using function notation here, I'm going to relate it to slope. M and then n minus 5. That is me using this form right here. Okay. So here's what I know. I do know that S of 11 is equal to S of 5, which is 31, plus m and then 11 minus 5. So S of 11 is 49 equals 31 plus 6m. Subtract 31 from both sides, divide by 6. Are we okay with me just like telling you that m is 3? Subtract by 31, divide by 6, m is 3. So S sub n is now S sub 5, which is 31, plus 3 times n minus 5. So I'm trying to determine how many seats are in the 25th row. So S 25 equals what? So it's fine. Plug in the 25. So 31 plus 3 times 25 minus 5. You're going to get a solid 91 seats here. And that is for S of 25. Okay. Beautiful. Let's do the same exact thing here using a geometric sequence, relating it to an exponential. So this is our first time talking about an exponential in AP PreCalculus. It's not bad. The b is the base here if I'm looking at the exponential function. B is the base. A is that initial value. So the same forms here. They match up pretty well. Take your own time to look at them and compare and contrast and see how similar they are. Given a geometric sequence here, I have g of 1 is 3. I have g of 4 here is 24. So g of 4 is equal to g of 1 times r to the 4 minus 1. This is when I'm letting n equal 4 and then k equal 1. It's supposed to be a 4. It looks like a y. Okay, well, what do I know? G of 4 again is 24 equals 3 times r cubed. Okay, divide both sides by 3. 8 equals r cubed. Cubed root both sides. Cubed root of 8 equals r. So r is equal to 2. Knowing that, we know that g sub n is equal to g sub 1 times r, which is 2, to the n minus 1. I'll give these some values. So 3 times 2 to the n minus 1. So there you go. That's one of the many acceptable correct answers. Let's do the same thing here for an exponential function with an input-output pairs as 1, 3, and 4, 24. So really is the same thing here. I'm going to relate that b base with r. So I already did all that work. So I'm not going to worry about that right now. So I know that b is 2. Okay. So y is equal to the a value, which I know that from this right here. A is the initial value, so a is 3. Okay, so I'm going to get 3 times 2 to the x minus 1. Okay, so this one I'm just relating right back because this is the same problem. So just kind of help you out there. All right, let's actually do an application thing. There's this wild rumor that's spreading that Coach Meinbauer won 3rd place in a World's Strongest Man contest. We all know how untrue that is. All right, so let's just not even believe that. Should have been first. The number of people that have heard the rumor can be modeled using a geometric sequence where 43 people heard the rumor on day 3. Let me go ahead and label that real quick. So on G3, 3rd day, 140 people knew that rumor. Sorry, I can't read. Should have been a problem about people starting a rumor that Coach Meinbauer can't read. Probably more realistic. So G of 3 is 43. I'll underline that, how I know that. And then 140 people on day 6. So G of 6 is equal to 140. And we're looking for day 10. So G of 10 is equal to what? So that's what we're going to figure out. All right. This problem does involve a calculator. So I advise that if you want to work this problem out too, you can use a calculator as well, because these numbers do get kind of radical. See, that's a fantastic joke if you knew at the ending, whatever. Okay, so using this form right here with the G sub n equals G sub k, I do, actually, I'm not going to use, I'll use G sub n. What does this represent? This represents the number of people who heard the rumor. Okay. So G sub n. So I'm using, if you notice, I'm using sequence notation here. It's because we're a little less aware of function notation with exponentials, but same thing here. So this is going to give me a G sub 3 times r to the n minus 3. So let's go ahead and do G sub 6. I'm going to plug in a 6 for k equals G sub 3, which I know is 43, r to the third, because I'm going to plug in a 3. So 6 minus 3 is, sorry, I'm plugging in a 6 for n. And so G sub 6 is 140 equals 43 r cubed. Tells us that r cubed is if we divide that 43 from both sides. So we'll get this value right here. So r is equal to the cubed root of 140 over 43, which is the same thing. Sorry, 140 over 43. I can't even write a 43 correctly. Same thing as saying 140 over 43 to the 1/3. They're the same thing, by the way. Just so you know. So for G sub n, I have G sub 3, which is 43 times 140 over 43, all to the 1/3 of n minus 3. So I just pulled that 1/3 up. So now I'm looking for G sub 10. Let's do it. G sub 10 is equal to 43 times 140 over 43, should be 0 right there, to the 1/3 times 7. This requires a calculator. So let me just go ahead and pretend I have my calculator out and I'm typing in the buttons. And enter. And oh, look, I get an answer of 675.578. A lot of other numbers I don't really care about. It wants me to know to the nearest whole number. So you can truncate or you can not, doesn't matter. I'll round up so we can pretend more people know about my rumor started I placed 3rd in the world's strongest man. People. All right. So there you go. That finishes our video here. And do not forget to like and subscribe.